So our focus in this mini lecture is the topic of the substitution rule. So if we take a problem that says to find the integral of x to the third times cosine of x to the fourth plus 2 with respect to x, that's a very challenging integral right there. So we're going to use this substitution rule. First step, let's let u equal x to the fourth plus 2. Right? We said u equal to what's inside of that parentheses there. So if you find u's differential, du, we can use the power rule, right? So we have 4x to the third, derivative of 2 is nothing, or 0 I should say, and it's with respect to x. Now let's take a look at this a little bit closer, what we just found out. After taking the differential, we have 4x to the third dx. If we look at that x to the third, right, and that dx, isolate that, x to the third dx, and you'll see why I'm doing it in a moment. The 4 is divided to the other side, so that's du4. Well, why did I do that? Well, if you look up here, we have x to the third, and we also have dx. Alright, so that x to the third dx we just said is du over 4. Right? Du over 4, or we can probably write that as 1/4 du. Alright, so let's keep that in mind. So now I'm going to rewrite that original problem. Rewrite that original problem as the cosine, and I'm not using x to the fourth plus 2, I'm using u. And I'm going to multiply it times 1/4 du, right? Because we have the x to the third dx there, and I can just put that together. Alright, so now I can bring the 1/4 out as a coefficient and take the integral of the cosine of u du. So this is a much easier integral than the original problem because we have antiderivative formulas for that. So this is going to be 1/4. The integral of cosine u is sine u, and don't forget to add the constant of integration. And then lastly, we'll write 1/4 sine, and instead of writing u, we'll replace what u was, which is x to the fourth plus 2 plus c, that constant of integration. So what we did was a really complicated integral and replaced it with a simpler integral. Alright, let's take a look at another example. Here we have evaluate the integral of the square root of 2x plus 1 with respect to x. The square root of 2x plus 1 with respect to x. So first let's let u equal that 2x plus 1 underneath the radical there. Alright, and then after such we can find what du is, right? So that's not too bad. Du is equal to 2 dx. So now we can say, okay, let's see what dx is equal to. Just by doing some simple algebra, dx is equal to du over 2, right? To solve for dx, you just divide both sides by 2. So now the substitution rule gives us, and if we were to rewrite the integral of the square root of 2x plus 1 with respect to x, I can rewrite that as the integral of the square root of u. And instead of dx, I'll write du over 2. Alright, so that du over 2, remember that's, you can look at that as 1/2 du, right? Means the same thing, just written in a different way. So I can pull that 1/2 out as a coefficient, right? And then say to myself, let's take the integral of the square root of u. Well, at this point, you've probably been working with a lot of radicals, and you know you can change that square root of u to the 1/2 power based on a mathematical definition. And then this is with respect to u. Okay, so now we can take care of this 1/2 and say, okay, the integral of u to the 1/2. So from this point on, you can go ahead and use those antiderivative formulas that you were given, and you would say this becomes u 1/2 plus 1 should get us 3/2 over 3/2 as well, based on the antiderivative formula for this, right? And then you can't forget the constant of integration. And then we'll just clean it up a little bit. We'll say 1/2 times the u to the 3/2 over 3/2. Well, you can just multiply straight across, and I'll get 1/3, right? So 2 times that 3/2 gets us that 3 in the denominator. I can change that u to what it originally was. The u was 2x plus 1, and that's raised to the 3/2 power. And don't forget to add that constant of integration to the end. And there we have it.